Hello all, this is Radhika Prabhu. I am working as an assistant professor in Hindustan Institute of Technology. Today in this video, we are going to see about some facts about the computer architecture. The topics we are going to cover in this video is as follows. So first one is the functional units of computer. We will be seeing about the basic operational units, memory organization and addressing, instructions and sequencing. So what is the course objective of these topics is to study the concepts of the basic structure and operation of a digital computer, and the other aim of this video is to implement the knowledge about the operations of the arithmetic and logic unit. Okay, first we will see about the functional units of a computer. Basically, the functional units of computer consist of these parts. So the thing is input unit, output unit. So these both are present in a IO unit. Okay. And next one is a memory. So the memory unit consists of all the instructions and also all the data which will be stored in the memory unit. And next one is a processor. The processor consists of the arithmetic and logic unit and also the control unit. So what is meant by the input unit is it accepts all the informations whichever is given by the human operators or an electromagnetical devices, mechanical devices or any other computers. So the input is given in the form of these things. That is known as the input unit. And what is meant by output unit is it sends the results of the processing. So whenever the input is fed into the computer, it processes the thing and then it sends the output to the computer in the form of a monitor or through the printer. So that is known as the output unit. And the ALU. So ALU is present in the processor, and what is the use of the ALU is that it performs a desired operation on the input information as determined by the instruction in the memory. So whether it want to perform the arithmetic operation or a logical operations, that will be performed in the form of the ALU. And next one is a memory. So memory, as I said before, it stores the information like data or the instructions. So the data is a collection of information, and what is meant by instruction is a set of data together is known as an instruction. And next one is a control unit coordinates various actions. So what are the actions performed by the control unit is that input, output, processing, everything is coordinated by the control unit that is present in the processor. So these things are known as the functional units of a computer. For example, we will consider a C program. So that is void main, and then we have declared some variables like A, B and C, and through the scanf, when this step is running, scanf is used to get the input from the user. So the input will be get in the form of A and B variable. So this input, consider the user is entering the input like A equal to 5 and B equal to 10. So that input will be fed into the IO unit. So what the input in the form of human operator or the electromagnetic mechanical devices. Okay, so when the 5 and 10 is entered into the input unit, it will be fed into the memory unit. It will be stored, the values of 5 and 10 will be stored in the memory unit, and then it will be led into the ALU. So in the ALU, if it want to perform an arithmetic operation or a logical operation, it will be performed according to that. So in this program, we had to perform the arithmetic operation, that is the addition operation. So the addition operation will be performed with the help of the ALU. So 5 and 10 will be added, and the result 15 will be stored in the memory C, so that is present in the memory unit. And while we print the output, that result stored in the memory will be fed into the output unit, and the result 15 will be printed in the output, and it will be displayed through a monitor or a printer, whatever it is. Okay, so this is a real-time example and how the input is fed into the computer and processes, and then the output is displayed in the monitor. Okay, and next is a computer system components. So what are the system components? So as we seen in this diagram, that will be briefly explained here. So memory, the memory unit, memory component stores the instruction and data, and the IO unit, it is called as a peripherals, and it is used to give the input and output instructions and data. And the ALU, it performs the arithmetic operations, addition, subtraction, etc. and it also performs a logical operations like comparing the two variables greater than, less than, equal to. These things will be performed with the help of the logical operations. And next one is a control unit. That control unit is used to coordinate the operation of the computer and the system interconnection and interaction. This is done by a term known as a bus. So what is meant by a bus? It is a group of lines used to transfer the bits between the microprocessor and the other components of the computer. So there are various components of the computer. These components are interconnected and the bits and the data are sent to all the components with the help of a bus. So a bus is nothing but a group of lines or wires. We can say simply a wires connecting the different components. So it is used to communicate between the parts of the computer. There is only one transmitter at a time and only the addressed device can respond. So what is a bus? It is used to transmit only one transmitter at a time, and also it is addressed device can respond for this transmitter. And what are the types of the buses? Address bus, data bus, and control signal. So by the name itself, address bus transfer the addresses to different component, and the data bus is used to transfer the data between different components, and the control signals means whatever the operation has to be performed, that control signals will be sent with the help of the bus. And next one is the registers. So what is meant by registers? It stores the old data, instructions, or any other items with various sizes will be stored in the registers. So next is a program counter and memory address registers. So this is also a type of register, and we will see in detail in the later upcoming slides. And it must be of same size or width as an address bus. And the next one is a control unit. It generates the control signals which are necessary for execution of an instruction, and it also connects the registers to the bus, and it also controls the data flow between the CPU and the peripherals including the memory. It provides a status, control, and timing signals required for the operation of a memory and the I/O devices. It also provides a status, whether the operation is performed, it is done, it is true or false, and if there is any waiting is done. So everything will be updated with the help of the control unit. It acts as a brain of a computer system. So like a human, in human everything will be activated with the help of a brain. Everything, our body parts and everything will be controlled with the help of a brain. So in the computer, the control unit acts as a brain. All actions of the control unit are associated with the decoding and the execution of the instruction, like fetch and execute cycle, and these fetch and execution everything will be seen in the later slides. And next one is the ALU. It executes the arithmetic and the logical operation, and there is a term called accumulator. So accumulator is a special purpose register, and it is also known as a temporary registers, and it stores the data temporarily when it is moving, when it is transmitting from one component to another. Source of one of the operands of an arithmetic or logical operation serves as one input to the ALU. So the final result of the arithmetic or logical operation will be placed first in the accumulator, then later on it will be displayed. After it is displaying as an output, it will be removed from the accumulator, and the next result or next operations result will be stored in the accumulator. So it performs the following arithmetic and logical operations. What are the arithmetic and logical operations? Addition, subtraction, and then logical operation includes logical AND, OR, exclusive or complement, and also increment, decrement, left shift, clear. So these are all the ALU operations. Next, so steps involved in the execution. So while after the input is given into the computer, the system is going to process the thing. So that processing is known as the execution part. So what are the steps involved in the execution part is, first one is fetch. So it will fetch an instruction from the memory. So whatever the data are given as an input will be fetched from the memory. That is the first step. Next one is a decode. So it will be decoded in the form of a machine understandable language. And next one is executing the instruction. So according to the input, it will be executing the instruction, and at last, after executing and the process complete, it will be stored as a result. So consider an example like this. So add R1, R2. So this is an instruction. So in this, first it will fetch an instruction. So what it means is it will fetch the data of R1 and R2 from the memory, and then it will be decoding those values, and then it will be executing the instruction. Like, so what is the instruction is add R1 R2. So it will add the values of R1 and R2, and then it will be executing it, and at last the values after adding will be stored into any of the registers. So R2 consider, and this will be stored as a result. So these are the steps in the execution process. Okay, there are few issues in the execution process. What are those issues? Where is the address of memory location from which the present instruction is to be fetched? Okay, what is the first step? To fetch an instruction from the memory, but where the fetching will be happen, from which address or from which place the data will be fetched? So that is a issue, right? And next question is, where is the present instruction stored while it is executed? So while the execution process going on, where is the present instruction that add R1, R2 is stored? So that is one issue. The next issue is where and what is the address of the memory location from which the data is fetched. So same thing, from where and what, which memory, which data is to be fetched from the memory. So these are the questions, and we have the solutions for these issues, and we will be learning that solutions in the form of a basic operational units. Okay, that is the next topic, and this is a basic processor architecture. And what is the first one is, so this is a processing architecture, and this is known as a processor. So the whole thing is known as a processor, and this is the memory. The processor is connected to the memory. And next one is, so what is meant by MAR? The MAR is known as a memory address register. It will store the address of the particular register. And next one is, so that is given here, so address of memory location to be accessed with the help of MAR. And next one is a PC. So what is the use of PC is, the address of the next instruction to be fetched and executed will be stored in the PC. So PC is simply known as a program counter. So address of the next instruction will be stored in the program counter. And next one is a IR. It is simply known as an instruction register, and in this the instruction that is currently being executed will be stored. And next one is a control unit, MDR. MDR is known as a memory data register. Data to be read into or read out of the current location will be stored here. Okay, the particular data which is to be read, that will be stored in the MDR. And these are the general purpose registers. R0, it starts from R0, R1, and it will be going on till Rn-1. These are known as the general purpose registers. And next one is a control unit. So as we learned before itself, the control is used to it controls all the processing in the two different components in a computer. And next is ALU. This also we have learned. It is a arithmetic logic unit, and all the operation will be performed in the ALU. Okay, so what is, we will see one by one registers in the control part. So IR is an instruction register, PC is a program counter, and then MAR is a memory address register, address of the memory location to be accessed, and MDR is a memory data register. Data to be read or read in or read out is stored in the MDR. Okay, we will see the operational steps, how it is accessed. Okay, so first step is programs reside in memory. Okay, so whatever program we are feeding into the computer will be residing in the memory. Programs execution starts when PC points to the first instruction. So what is the purpose of PC? What's the purpose of program counter? It stores the next instruction to be executed. So at the beginning, the PC contains a first instruction to be executed, right? That will be the next instruction for the program counter, because at the beginning it will be 0. So the next instruction is the first instruction of the program. And the contents of PC are transferred to MAR. So in the diagram, just imagine the contents of the program counter will be transferred to MAR, and read operation is initiated, and then addressed word is transferred to MDR. So after feeding into the MAR, it will be transferred into the MDR. That address, that particular location will be fed into the MDR, and the contents of the MDR is transferred into the IR, because IR means instruction register, which consists of the current currently executing instruction. So that MDR content will be fed into the IR because that is the currently running instruction. And then operands are fetched from the memory. So now next it has to perform the ALU operation. For the ALU operation, it has to fetch the operand. So what is memory operands? The variable, the values which is fed into. Consider the example before we said add R1, R2. So the R1 and R2 is known as the operands. So that should be fetched from the memory to MDR and it will be transferred to the ALU. And the ALB will performing the operation. So add R1 R2 means it will add the value of R1 and R2 that will be performed with the arithmetic logic unit, and the result can be stored in the memory. Now the value in MDR and address in MAR, so that will be the result, and write operation is performed at the last. After reading everything and processing, that will be the output will be performed in the write operation. So next is the memory organization and the addressing. So in this we will be seeing about the computer instruction must be capable of performing 4 types of operation. There are basically 4 types of operation performed by the computer. First one is the data transfer or the movement between memory and processor registers. For example, read, write, those things. So data transfer is happening. Reading means the data is fed into the system, and then memory write means from the memory the output will be fed. Okay, so that is a data transfer. And next operation is a ILU, and the next one is a program sequencing and flow of control, and next is a input and output transfers. So examples for these steps. First, what we have seen is a data transfer. So for this example, this is the instruction. So move A comma B or move A comma R1. So data transfer is happening. The value of A is moving into the B, and in this the value of A is moving into R1. So this is a data transfer. And next is a ALU. For this example, add. So add instruction acts as a arithmetic operation. So adding A, B and C, and the result will be stored in the C. So this is the example. This instruction is an example for the ALU operation. And next one is a sequencing. So sequencing in the sense jump label. So for in the sense, consider the instruction has to be jump from step 2 to step 5. Okay, so that will be performed in the form of a branch instruction, and that is known as a sequencing. And next is the last one is a IO data transfer. So input port comma R5. This is an example for the IO data transfer. So this means it read the IO port to register 5. So it will input the port value to the register 5, or it output. If you use the word output, it will be outputting the port value to the register R5. So these are the basic steps. Next, specifying the operands in the instruction. So already we have seen what is meant by operands. In add R1 comma R2, R1 and R2 is known as the operands, in which the values are stored. So operands are the entities operated upon by the instruction. Operands may have to be fetched from a memory location to execute an operation. Operands may also be stored in the general purpose registers. And specifying the operands on which the instruction is to operate involves specifying the address of the operand. So in order to specify the particular operand in which the instruction is operated, so the address of the operands should be specified. Consider the operations may be specified as how operation, and then source 1, source 2 and destination. So this operation will be like add. Source 1 is R1, source 2 is R2, and then destination is R3. So this is the same kind of example. Add A, B, C. So in this, add is a operation. A is a source 1, B is a source 2, and then C is a destination. An operand is called a destination operand when it is called as a destination operand. So in this, we are going to add A and B, and we are going to see the result in the C. Store the result in the C. So in this type, C is acting as a destination operand, and A and B also is known as a source operand. So these are some of the examples. Add A comma B, and in B is both the source. So like in this type of example, at the beginning A and B both are the source operands, and at last the value of A plus B will be added and it will be again stored in the B. So now the B will be acting as a destination and the value of the source operand will be replaced by the addition result. Okay, so basically instruction types are classified like this, like 3, 2, 1, 0 operand addresses. So first one is a 3 address instruction. See, in this add A, B, C. So there are 3 address A, B and C is there. So this is known as a 3 address in the instruction, and the value of A and B will be added and it will be stored in the C. And 2 address means there will be 2 operands A and B, and as we seen before, the B will be acting as a source operand and also it will be acting as a destination operand. And what is one address instruction is, example, clear A. So it is only one instruction, only one thing is performed here. So clear A means A will be, the whatever values are stored in the A will be cleared and will be set to 0. Okay, and 0 address instruction is, there is no operands present in the 0 address instruction. Simply the instruction will be like this, halt. So it means that the computer will halt for sometimes, it will wait for sometimes. Okay, so that is known as a 0 address instruction, because it means that 0 address means there is no operands or no values are stored in the memory. So there is a address is 0, address is empty. Okay, how are the addresses of operands specified in the instructions? So what is the form? How are the addresses of the operand specified in instruction? The answer is with the help of the addressing modes. So these are the addressing modes. We have seen 3, 2, 1 and 0. Okay, and then next topic is, we are going to see about the instructions and sequencing. So in order to complete a meaningful task, a number of instructions need to be executed, of course. So if you want to run a program, there will be number of instructions and those instructions has to be executed to complete a task. So first is, during the fetch or execution cycle of one instruction, the PC is updated with the address of next instruction. So that we have seen that PC is used to store the address of the next instruction to be executed, and when the instruction completes its fetch or execution, the content of PC points to the next instruction. So if there are some 10 lines of instructions are present, first PC will be containing this first instruction, and when that is completed, it will be, the PC will be replaced with the second instruction. So thus a sequence of instruction can be executed to complete a task. So consider a simple task, adding two numbers stored in the memory location A and B, and then store the result of addition in memory location C. So for that, what are the steps of instruction to be followed? First, we have to move the content of A to R0, and then we have to add the content of B with content of R0. So R0 is already containing the value whichever given in A, and we are just moving the value of A to R0. So consider A is having 5 and B is having 10, and now add B comma R0 means it will add B is 10 and A is 5 means it will add 10 plus 5, and then the result will be stored in the R0, like a 2 address instruction we have seen, right? So this will act both like a source operand and also a destination operand. Now the value of R0 is again stored into the C variable. We are just moving the content of R0 or the final result 15 to C. So that is represented in a diagrammatic form. So in this, first move A comma R0 will be present in the first instruction, the first register that contains the address 0. For each instruction there will be 4 bytes. Consider the size of the memory is 4 bytes. So first instruction will be present in 0th byte, and then what is the step 1? PC holds first, initially it will be 0, and then it fetches the instruction at address 0. So address 0, it contains the instruction move A comma R0. So this instruction will be fetched in the PC. It fetches the operand A, and then it executes the instruction and it increments the PC value to 4 because the PC's next address is 4. So it will increment the PC value to 4, and it will now, the PC holds the address 4. Okay, now in the fourth address, what is the instruction present? Add B comma R0. That will be fetched, and the value of operand and also the execution will be done here, and then it increments the PC to again 8, and the next next address is 8, and then it will go and fetch the instruction present in the 8th location. So again now PC holds the address A, it fetches the instruction, it executes the instruction and stores the result in the location C. So this is a simple execution or a sequencing, a straight line sequencing. It is also known as a straight line sequencing. Next, consider the following task: add 10 numbers. So okay, like this, in this before example there are only 2 numbers, we are just adding and we are storing the result in the some variable. Consider there are 10 numbers to be added. So there will be how many instruction steps? There will be lot of instructions like move num1, 0, add num2, 0, then num3, 0. We have to add until 10. So there are more number of instructions in this type of example. So what is the issue in this? There will be more number of programming steps, which creates a problem. Okay, which creates a lot of memory storage. For every instruction there will be a particular storage, and there will be lot of memory occupation. Okay, now so in order to solve this problem, what we are doing is separate, that is given here, separate add instruction to add each number in a list, leading to a long list of add instruction, and this task can be accomplished in a compact way. There is a method in order to accomplish this in a compact way by using a branch instruction. So consider this: move n, r1, and then we are clearing the value of r0, and we are using a concept called loop. So loop means it will repeat the same steps by replacing the value. First it will add r0 and r1, and r1 will be replaced by the final result, right? So add r0, r1 means it will add the value and it will store the value in the r1, and next step it will perform the loop. So in this, the register value will be incremented and it will add the r1 or r0, r1 with r2, and then that value will be replaced in the content of r2, and the looping will be repeated again and again, because the same operation is performing 10 times, right? So for this we are using the loop concept. So until the branch is greater than 0, the looping will be performed. This is the condition. So until this condition satisfied, the loop operation will be performed, and at last r0's the final result will be stored in the variable sum. So this is a branching instruction technique. In order to reduce the more number of instruction lines, we are using this technique. So that is given here, that explanation is given in this slide, whatever I told. So it will check the condition until the count in register r1 is 0, until then the loop will be performed. Next, so okay, so that is given in the diagrammatic form also. So move num1 r0, and this will be stored in every instruction. See, listen, so this is the first address, the first instruction is stored, and then plus 4, so 0 in 4th address, next instruction will be stored, and then 8th address, next instruction. So it will be going on like this. So it will occupy more number of addresses, memory locations. So in order to avoid this problem, we are going into the branching. So you consider in this only few addresses is allocated, right? So this is 0, this is 4, and this is 8, this will be 16, 8 plus this will be 12, and the same thing is repeated in these steps itself. The looping will be performed. So this lines occupied in the before straight line sequencing is avoided in this type of instruction branching. Okay, now consider if information is recorded in individual bits. Okay, so consider whether the data is available or data is not available, the condition is true or false, whatever it is, those information will be recorded in the form of individual bits. That is called as conditional code flags. So what are the flags? These are the types of flags. First is N, Z, V and C. So what is N? N is a negative. It is set to 1 if the result is negative. So if the final output is negative, it will set the N value to 1. Okay, and if the final result is 0, it will set the Z value to 1. And if the final result is overflow, so consider when we are adding two binary bits, So sometimes there will be overflow occur. Okay, so 1 plus 1 is 1 0. So at this time 1 is an overflow. So for this purpose the V is used, the V flag is used. So that will be set to 1 when there is a overflow. And the last one is a carry flag. So when we want to add something or subtract something and the data is not available, the bit is not available, it will carry another bit from the before number. So that in that case C, the C flag will be set to 1. So flags are grouped together in a special purpose register called the condition code register or the status register. It is also known as a status register because it is displaying the current status, whether it is the result is negative or 0 or overflow or carry. So these status is displayed here, hence it is known as a status register. Okay, and then there is a branch instruction, alter the sequence of program execution. So what is the purpose of branch instruction is given, whatever I have explained in the before diagram, it is given. The processor fetches and executes the instruction at its new address, and instead of instruction located at the location, new address is called a branch target. That new address is named as a branch target. Okay, and conditional branch instruction calls a branch only if a specific condition is satisfied. And conditional branch instruction use a condition code flags, as we seen some of the flags like N, B, C, these and Z. Okay, these flag will be used to denote the status of the conditional branch instruction. Okay, so by this we have seen all the topics. So what are the we will just summarize the topics we have seen. In the first functional units of computer, we have seen about the input unit, output unit, ALU, control units, etc. And in the second one we have seen about the basic operational units. So with this help of these units, and also something deeper inside like MAR, MDR, register, memory, and purpose of these things we have seen in the basic operational units. And in the memory organization and addressing, we have seen different types of addressing modes like 3 address, 2 address, 1 address, 0 address, etc. And also we have seen how it is stored with an example instructions. And the last one is we have seen about the instructions and sequencing, and in this we have seen two types. One is a straight line sequencing and next one is a branching instruction sequencing. Okay, and we have seen with few examples also. Okay, and at last the course outcome of this topics is, at the end of the course, the students can able to identify the basic structure of digital computer. I think we have covered the basic structure of digital computer and instruction sets with addressing modes, and also the student can able to comprehend the arithmetic operations performed in the processor. So this will be the course outcome. Okay, we will we'll be seeing a crossword puzzle related to the topics we have seen. So this is a simple gaming puzzle. So these are the questions given here. So first question is try to answer these questions. The central processing unit and memory are located on the, so this is the one is present here and it will be coming from top to down. And second question is, conversion of computer generated results into human readable format is a function of dash, and dash is used to hold and transfer instruction and data that are being immediately used by CPU. That will be the third question. And the fourth one is, a CPU register contains the instruction currently being executed is called. I think you can just review these questions. These are the following answers for this crossword puzzle. So 1 to 10 questions are here and the answers are given here. Okay, thank you. By this I will end the video. Hope you all have a clear concept about this the topics we have covered. Thank you so much.